Okay, in this question we have to start by completing the square. So first step is to take a factor out of the first two terms, whatever this number is here, a 4. You can actually, in this problem, take 4x out as a factor of the first two terms, and you'll get a slightly different looking result, but it's equally valid. But normally you just do this, use square brackets, because you're then going to you're going to complete the square of the contents of the square brackets, which involves another set of brackets. So if we do that, halve the minus 3 to get minus 3 over 2, take away the square of negative 3 over 2, always subtract here, whether you've got a positive or a negative here, you always take away here, because you get a square of this negative term, which will be positive, and we don't want it, so we take it away. Don't forget the plus 11. And then we do 4 times this bracket, and 4 times the minus 9 over 4, effectively expanding the square brackets. And then finally combine the minus 9 and the 11, and there we have our answer. Okay, in part 2, state the number of real roots of the equation. That's the expression we've just completed the square of, equals 0. State means that we shouldn't have to do any more working. We should already have enough information to know the answer. It's just for 1 mark. So if you set this thing here equal to 0, is it possible for that to equal 0? Well, no, actually, because here we have a square thing, and square things are either positive or 0. They can never be negative. And so a 4 times a square thing, again, the minimum that can be is 0. And then we're adding 2 to it. So the minimum this whole expression can be is 2. So can this expression equal 0? No. So there are 0 real roots. And if you plot the graph, you can use the fact that we've got this in completed square form to say that the minimum will be at 3 over 2, 2. That's here. You can see that it's got no roots, it doesn't touch the x-axis. And then we've got to, in part 3, extend that concept to discuss how this number here, they've called it r in their slightly more generalised version of a completed square equation. How does this value of r define the number of real roots of the equation? Well, let's go back to what we were thinking before. This was a square thing, or 4 lots of a square thing, plus 2. The fact that we were adding 2 meant that we're sort of taking this curve and raising it up 2. If that 2 wasn't there, and it was a 0, then the graph would just kiss the axis. You get a repeated root. And if it was negative, you get 2 roots. Let's see what's going on here. So if r is positive, like it was in the rest of the question, you get no real roots because it looks like that. If r is 0, you get a repeated root because the graph will look like that. And if r is negative, you get 2 distinct real roots because it crosses like that. You've got this negative value of r, just brings the curve down to this far below the axis.